So your quiz is on 4.1 and 4.2. Your review covers that. You're going to have 7 questions on there. You'll have a log question, an exponential function question. You'll work with compound interest. It could be one that's like the first 3 here or one that's continuous. You're going to be evaluating functions where x is in your power, as well as working with functions that have e in them. And you'll also identify transformations. So like I said, 7 questions on your quiz. We're going to start your review with your compound interest. Your first question tells you that Lauren initially invested $1,580 into her savings account. The interest rate on that is 2.35%. How much money is in the account after 6 years? Use the following conditions to evaluate. So if you look at A through C, we're looking at quarterly, monthly, and weekly. That means that your formula is going to be A of T is equal to P, which is your principal, times 1 plus R over N to the power of N times T. That's for examples A, B, and C. You'll use that formula. For something like example D, you'll use A of T is equal to P times E to the power of R times T. So A per. Okay. Ultimately, when you look at all of this, it tells you that your P is the 1580. Your R, or your rate as a decimal, is 0.0235. And your time, or T, is 6. So if we look at our first part, it says quarterly. That means we're going to be working with an N of 4. So I'd write down that N is equal to 4. So if you plug these values into your formula, you're going to have A of T, which is 6, is equal to 1580 times 1 plus 0.0235 over 4 to the power of 4 times 6. Now you're going to have to write all of this down tomorrow as well. So anything that's going to go in your calculator, I need you to write down on your quiz. Okay? If we round to 4 or to 2 decimal places, since we're dealing with money, we get that A of 6 is equal to $1,818.50. For example B, we have monthly. That means that our N, there's 12 months in a year, N is equal to 12. So we're going to plug all of this stuff in. We have A of 6 is equal to 1580 times 1 plus 0.0235 over 12 to the power of 12 times 6. Plugging this into our calculator and rounding to 2 decimal places, we should get A of 6 is equal to $1,819.00. For example C, we have weekly. There's 52 weeks in a year, so that means that N is going to equal 52. Plugging this all in, we get A of 6 is equal to 1580 times 1 plus 0.0235 over 52 to the power of 52 times 6. So again, plugging this all into your calculator, hitting that enter button and rounding to the second decimal place, you should get that A of 6 is equal to $1,819.19. For example D, we are compounding our interest continuously. So that means we use the formula A of T is equal to P times E to the power of R times T. We said our principal is the 1580, our R is the 0.0235, and T is 6. So this is going to give us 1580 times E to the power of 0.0235 times 6. Plug that into your calculator, round to the nearest hundredth or second decimal place. Since you're dealing with money, you have $1,819.25. If we look at the next part, you're evaluating for each of these. For number 2, it gives you f of x is equal to 1/4 times 1/3 to the power of x plus 1. You're just plugging these x values into your calculator and simplifying. So for example A, we're given that x is equal to -2. This is going to give you -4 times 1/3 to the power of -2 plus 1. So this, if you plug it in correctly, is just -35. For example B, we have x is equal to 2/3. So we're going to just do -4 times 1/3 to the power of 2/3 plus 1. Again, plug this into your calculator. If you plug it in correctly and round to the 4th decimal place, you should get -0.9230. So for example C, you have x is equal to the square root of 5. So that's going to give us -4 times 1/3 to the square root of 5 plus 1. So this then, if you plug it into your calculator correctly and simplify, you should get 0.6571. For your next example, you are using the function f of x is equal to -2e to the power of -x plus 3 minus 5. For A, we're given x is equal to 4. So if x is equal to 4, this is going to give us -2 e to the power of the opposite of 4 plus 3 minus 5. So we're going to plug this into our calculator, round to the 4th decimal place. That should give you -5.7358. For B, we have x is equal to -2/7. Again, plugging this in, we would get -2 e to the power of the opposite of -2/7 plus 3 minus 5. You should plug this into your calculator and get -58.4561 as your answer. For example C, you have that x is equal to the square root of 2. So this is going to give you -2e to the power of the opposite of the square root of 2 plus 3 minus 5. So if you plug this in correctly and you simplify, round to the 2nd decimal place, you should get -14.7663. Then for example D, you have pi. So that's going to give you -2e to the power of the opposite of pi plus 3 minus 5. Plug it in, round to the 4th decimal place, you should get -6.7359. For examples 4 and 5, you're describing all of the transformations. For number 4, we have f of x is equal to the opposite of 3/4 times 3 to the power of -x plus 2 minus 8. The negative that's in front of the 3/4 is a reflection. Remember, anything out front or in the back is vertical, so that reflects over your x-axis. Next, we have that 3/4. It's in front, it's not attached to the x, so we're going to keep it the 3/4. 3/4 is less than 1, so that means we have a vertical shrink by a factor of 3/4. Next, the 3 that's in the parentheses, don't worry about it. That just tells you whether or not you have a growth or a decay, which you don't need to give me. However, the x is negative, that's up top. So that reflects horizontally. It goes over your y-axis. So reflect over y. Then you have that plus 2. Think opposite since it's up top. You're going negative 2, so that's to the left 2 units. And lastly, that minus 8 means we're going down 8 units. For number 5, we are given f of x is equal to 5 times 3 to the power of 9x minus 1. The 5 out front means that we have a vertical stretch since it's bigger than 1 by a factor of 5. The 9 in front of the x up top becomes 1/9. The 1/9 is less than 1, so that's a horizontal shrink by a factor of 1/9. And lastly, that minus 1 just means we're going down 1 unit. So domain functions, exponential functions. Your domain is always all real numbers, always. Your range comes from your shifts up or down. If you don't have any and there's no reflection happening vertically, then your range is from 0 to infinity. If you have a plus a number or minus number at the very end like you do in number 7, your range is going to include that number. So in number 7, your range is going to be from 2 to infinity or from negative infinity up to 2, depending on which way that graph is running. Your horizontal asymptote comes from the number in your range. So if you do have a plus a number, minus a number, it's just going to be y is equal to that number. For your y-intercept or your x-intercept, your y-intercept, plug in 0 for x, solve for y, give the ordered pair 0, comma something. X-intercept, for these, there should be none. Okay? So for your domain for number 6, number 6, you have f of x is equal to negative 1/3 times 6 to the power of 2x. Typically, these graphs will look like this because you have a 6 and there's a growth happening. So it would look like this. However, the negative that's out front does what to this graph or this line? It flips it, and it flips it vertically. So it's going to become the line that looks like this. Okay? So from here, state your domain. Automatically, the domain is from negative infinity to positive infinity. Your range, those are the y values that are being covered. This graph is going down, so it's going from negative infinity up to a number. Do you have a plus or number or minus number at the very end? No. So that's going to be 0. Horizontal asymptote is y is equal to a number. That's the number in your range, so y is equal to 0. Your y-intercept, you're going to plug in 0 for x, solve for y. You're going to do f of 0, so that's going to be y is equal to negative 1/3, negative 1/3 times 6 to the power of 2 times 0. 2 times 0 is 0, so that's negative 1/3 times 6 to the power of 0. Anything to the power of 0 is 1, so that's negative 1/3 times 1, which is just negative 1/3. So that gives us the ordered pair 0, comma, negative 1/3. So for number 7, you have f of x is equal to 5 times 2/3 to the power of negative x minus 4 plus 2. Again, you start with the function that looks like what? Look at the number in the parentheses. It's 2/3, it's less than 1, so you're going to have a decay. So that means it looks like this. Is there any reflections happening? Well, yeah, you have one up top in front of that x, so it reflects horizontally, which means it becomes this graph or this line. So give the domain, range, horizontal asymptote, and y-intercept. Automatically, what's your domain? All real numbers, so negative infinity to positive. Your range, do you have a number that's a plus a number minus a number at the end? That's the 2. So your range is going to be working with that 2. Are you going up or down with this line? Up. So that goes from 2 to infinity. What's your horizontal asymptote? Y is equal to 2. Y-intercept, you're going to plug in 0 for x, solve for y. So find f of 0. That's going to give you y is equal to 5 times 2/3 to the power of the opposite of 0 minus 4 plus 2. Use your calculator for this. So 5 times 2 over 3, or 2 divided by 3, to the power of negative 4 plus 2 gives you 437 over 16. So your y-intercept is the ordered pair 0, 437 over 16. For 8 and 9, that goes over log functions. With the log functions, what you're going to want to do is first put down your range. Your range is automatically all real numbers, so from negative infinity to positive infinity. From there, you are going to look at what's inside the parentheses. Take what's inside the parentheses, set it equal to 0, and solve. You will use that for your domain and your vertical asymptote. You need to pay attention to your reflections as well, okay? These functions start off looking like this, okay? If there's a reflection happening, it will happen to that line, okay? So it's kind of like an upside down L. For number 8, it gives you g of x is equal to log 5 of 3x minus 7. The base on that log, which is the 5 right now, is irrelevant. We're looking at what's inside. We said the first thing that we're going to put down is what? The range, which is from negative infinity to positive infinity. Next, we use your parentheses. Inside the parentheses, you have 3x minus 7. Set it equal to 0 and solve. Move your 7 over, adding it to both sides. That gives you 3x is equal to 7. Then divide each side by the 3. And you get that x is equal to 7/3. Automatically, that is your vertical asymptote. So you can put that down as your vertical asymptote as x is equal to 7/3. Now look at your domain. Domain is right to left. Are you going to the right or the left? The right. So this is going from 7/3 to positive infinity. For number 9, you have g of x is equal to log 2 of negative 5x plus 12. First off, you would have a line that looks like this. So, do you have any transformations that are reflecting here? You have a negative in front of that 5. It's not in front, it's inside with the x, so that reflects horizontally, side to side, which means you're going to turn into this. So it becomes that. Automatically, what's your range? All real numbers, so from negative infinity to positive infinity. To find your domain and your vertical asymptote, what do you need to do? Set the negative 5x plus 12 equal to 0 and solve. Move your 12 over, subtract it from both sides. That's negative 5x is equal to negative 12. Divide each side by the negative 5. You get that x is 12/5. Automatically, that's what? Look at your domain. Domain is x. Is this pointing to the left or the right? Left. So since you're pointing to the left, it's going to negative infinity, which means you're going to start at negative infinity and go up to 12/5.